Hey, welcome back to Adventure World in Godot. In this video, we're going to do something called refactor our code, which means we're going to change the code to be a little bit easier, cleaner, and easier to use. But we're also going to refactor it in a way that will allow us to add more enemies without doing so much code duplication. And in order to do this, we're going to use something called object-oriented programming. And let's look up the wiki real quick. And basically, object-oriented programming is a programming paradigm based on the concept of objects, which contain data and fields and properties. And there's, you can read through here, and it sounds really complicated, but we're going to look at it from a really simple perspective. So I've prepared a couple of diagrams here, and a real basic example is to use animals. So I'm going to unlock this. So you have the kind of general class of animals, right? But then you can also have, I'm showing the wrong one. So let's take two classifications of animals, like dogs and fish. And so dogs and fish are two different kinds of animals, and they're both animals, right? But they're very different, and they have different properties. So for instance, fish may have, let's see, fish have scales, right? Let me turn down my opacity here. I apologize for the scratchy handwriting. I'm just getting used to my tablet. Alright, so I've got fish and they have scales, but dogs have fur. Alright? So there's a couple of, let's say, properties of these two animals, right? Now we can also show these, and so now we have a dog and we have two different kinds of dogs. And so, beagle may have long ears, and poodle may be fluffy. So these are properties of these specific types of animals. So not all dogs are fluffy. Some of them have short hair, and some of them have short ears. Alright, but all dogs have fur, and we can make a general property up here, say all animals like to eat. Right? So therefore, a poodle likes to eat because he's a dog, and all dogs are animals, and all animals eat. So that's just a little kind of high-level overview of what how this kind of inheritance or object-oriented programming works. Alright, so let's look at this from a different perspective. What if we had our kinematic body, 2D, which is what we have already, that we make our player and our enemy off from, and then we put in this new class called actor, and then off from actors we have all our different types of actors, like our player, our snail that we made, and maybe new ones like bats and whatever other enemies we add. We could also add NPCs, or something like a merchant that sells things to the player but doesn't necessarily attack the player. So those would be things that could also be actors. So we're going to look at how to implement this in Godot. And so to do that, what we're going to do is hop over to Godot, and real quick, one thing I did change between videos is I had to redo some of this. So what I did is I changed our enemy folder to be actors. And so I'm going to move all of the actors in there. So I'm actually going to move the player actor over here, as well as the player script, if I can find it. There we go. Right. So now I should have the player over here and the enemy snail over here. And my screen should still be fine. So there we go. Game still works just as before. But we've got it refactored to put those folders all together. Alright, so back on track. So what we're going to do is we're going to create a new class in here called actor. Alright, and so to do that, if we jump over to our script and we go up here to file and we say new, we can create a script that's not related to a node. So in the past, we've always created a script by attaching it directly to a node. So here we're going to just create one. And we don't just want it to be inherited from node. As we saw in our diagram, we want it to be inherited from this kinematic body 2D. So what we're going to do is type kinematic body 2D. Alright? And we're going to hit create. Oh, wait. I don't want to put it here. I want to put it in that actors folder, just like that. Alright, very good. So now we've got the actor script here. Now we can put things here, and they will be shared. Well, when we get done, they'll be shared between our other actors. So as a quick example, let's just put a print function, and we'll make it print for both our player and our snail. So what we're going to do is say print and say I am an actor. Alright? And then we'll also add and my name, well, we'll just say my name is, and then we'll make sure and convert it to a string, which we probably don't need to, but we'll do it anyways. And we'll just use name. So name is actually a property from a class up here called node. So if you look at node and you come down here to these members, you'll see name there. So we're already using object-oriented programming before. And so kinematic body inherits from other classes all the way up to a basic node, right? And therefore all these things are available to us when we extend from the kinematic body. Alright, so we've got our print statement in place, but now let's make our snail and player inherit from that. So to do that, we jump over to our player script, and up here at the top we say extends kinematic body 2D. And this is how GD script, or Godot, inherits from another class. So what we need to do is convert this to say actor. But I can't just say actor, and you notice it's all grayed out, because in Godot this is a resource on the disk and not a implemented class. So what I need to do is kind of tell it where that's at. So I'm going to say res/actor.gd. And that's just like I do for, say a scene file and all that kind of stuff. You have to define that out as the path to that file. So that's one thing that's a little bit different about GD script than maybe other languages. Okay, so we've got that. That's all good. And now let's do it to our snail. So we jump over to the snail and we do the same thing there. Save that. So now both player and snail inherit from actor. So if I start my game and I say new game, I'll get an error. So it could not load, and that's because I put this in my actors folder. So this is actually actors/actor. Alright, so let me do that same thing over here to snails, and we'll stop and restart. My bad. Alright, there we go. Everything works as before, but if you look down here in my output window, I'm an actor and my name is player, and then my other one is enemy snail. So that's awesome. So now we are able to use this object-oriented programming to create this intermediary class called actor, right? And we can apply logic and have properties and all kinds of stuff here that are shared between both my enemy snail and my player. And this is really important because if you look through here, if you look at our enemy snail specifically, there was a lot of stuff that we duplicated between the player and the enemy snail. So our goal here in the next part of this video is we're going to refactor this to move as much out of this script and out of our player script as possible and move them up into this actor script. Alright? So that'll make both our player script and our snail script look a lot simpler, which will make them easier to maintain and work on, but also eliminate having to have, say this whole block right here can move, and it won't be in both the player script and the snail script. It'll just reside here in the actor script. So let's go ahead and get started with that. So this movement stuff is pretty much all the same. We may want to adjust some of our speeds in the future, and we'll see how to do that. But all these variables still need to be there. So let's go ahead and move that up here to the actor. Alright, and so let's actually probably could use that. Now, if you had a case where so for instance, when you look at this scene right here, what we had to do is determine what things were unique about, that were always true of that level. So, you know, all dogs have fur, but but not all dogs had long ears, right? So we had to move those properties down to the lower level. And the same thing here. I don't want to move this up into the actor, right? If I'm going to have enemies or players and stuff that don't have this animated sprite. And that's possible, but I think for now it would be fine to move it down. Alright, and let's see. So this is unique, right? Because the player's not going to hurt things in the same way that the snail does. So let's leave that there. And so in this physics process, we're always doing this, right? We're always doing the move and slide. So let's move that. And that was in the physics process. So I need func physics process delta. And I need the move and slide. Now, I always am going to have this block of code, right? So here I've got this block of code that I want to do before I do my move and slide. And here in the player script I've got a big block of code, all this kind of stuff that I want to do before the move and slide. And when we first started, we put these in the process function and also in the physics process function, but we're just going to move them all into the physics process function. So what I can do here is I know I'm always going to have some behavior that I want to happen that's unique to this actor. So I'm going to call a function here. So I'm going to say actor behavior. Alright? I'm going to pass it that delta. And I'm just going to call it. Well, we need one here so that it doesn't crash. Right? So if we just had any old actor, right? We don't want it to crash. So I can do func actor behavior delta pass. Alright, so this would run and it wouldn't cause any errors because it would just call this function and then it would do nothing and then it would continue on. But what we're going to do is we're going to override this method in our player and enemy snail so that we can have code execute right here in this physics process without overriding the whole physics process, because if we did that then we'd lose our move and slide and any other code that we wanted to put here. So let's look at that real quick. So all I really have to do, I don't need this anymore, and all I really have to do up here is just change this to actor behavior. Alright, so now what will happen is the actor code will call actor behavior, which will go to the player and say, oh, here's an actor behavior, and it'll run all this stuff, and then it'll come back and then finally do the move and slide. So I hope that makes sense. And let's look at it from the enemy snail. So I'm going to do the same thing here, actor. Alright, delta, and we do all the gravity and all that such just like before. And I think our snail is ready. Let's look at our player. So there's some more stuff up here that we can move, right? So we've got health. We definitely want to have health. We'll go ahead and do water. And we already did the movement. So let's move that, delete that, and we'll go up to actor. Let's put in the water and the health. And we don't need these two things because these are specific to the player, displaying his health hearts and then also moving him when the scene starts. But we do want this hurt, the pass out, the knockout, and the entered and exited water. So grab all those and we'll move those into the actor. Alright, so we're going to put them, let's see, down here I think would be good. Well, wait, we'll put it right here. Alright, so, excuse me. Alright, so we're going to have to do a couple more refactors to make this work. So if we just play this as it is, probably get an error at some point. Yep. So right here, we got a hurt call. Let's see. So update on null. So yeah, right here, the snail hit the spikes, excuse me, called hurt on yeah. So since we moved hurt, I was trying to sort out where this was going. So before, our snail did not have the hurt method, but now it does because it inherits from actor, and actor now has the hurt method. All right, so I know that's getting a little bit crazy, but if we go back here and we look at our thing here, then I can draw on here what's going on. So our, let's see, actor has hurt, all right? And so now my snail has a hurt method because he now inherits from the actor. So what happened here is, if we go back to our code, we'll see this method is getting called, and then it's trying to say, hey, get me this HUD canvas layer. Well, the snail doesn't have the HUD canvas layer, right? Because he's not a player. The player script has that, so if we click on player, the player has that HUD canvas layer, but the snail does not. So we have a couple choices here. We could refactor in a couple ways, but what we're going to do is we're just going to, let's see, I think what we'll do here is we'll just check to see if this HUD layer is here or not. So the way we can do that is we can say if get node blah blah blah, and that should work. And the reason this works is it says if this method returns nothing, which that's what Godot does if it can't find it, then don't do anything. But if it does return something, then go ahead and run the code afterwards, and the code afterwards is going to call that update health. Alright? And so we're going to have, let's go ahead and stop that and play. And we should get it, we'll probably get a different error, but hopefully we won't get that one. Alright, so now we're past that hurt method, and we're down here in this knockback. So in the knockback, we're trying to play the flash animation on our animated player, right? So we don't have the animated player, so we need to do the same thing here. So I can say if animated player, then do that. And I think it's down here as well. Yep. So we're yielding on this animated player finished. So we'll probably return and fix this later because we do want to have a flash animation, just not yet. So let's see if that works. It's alright. So I got a little bump there, which was interesting, and that was because the hurt method actually played on the snail, so the snail probably took some damage by hitting that spike. But then he hit the player, so it's all good. I think if I jump out of the way though and that hits the water, I'm going to get another error. And this one is, let's see, yep, here at the splash position. Very same thing. I'm trying to get this node called splash position, but it's not on my snail. So you may be thinking at this point, man, this is a lot of work for this. Well, it sort of is, but the more similar your objects are, the less of this type of refactoring you'll have to do. And I think in this case, I actually want my snail to make a splash. So let's go ahead and add one. Alright, so let's add the splash position. Let me stop. I'll go into my 2D mode. I'll look at my snail. Let's add these are position 2D, and I'm going to rename it to splash position 2D. Alright, And I'm going to move it down like about there. Alright, so that's good. So now if I play this, I'll probably get another error, but hopefully it won't be because of this splash. So get my player out of the way, and yeah, we got another one, but this one is the sound. So this is an interesting case. So before, we put the sound directly on the snail, but what I probably should do is, for playing a splash sound, so we probably should just put that everywhere. I could put another copy of it here on the enemy snail, but you know, I may end up having to add a splash to all my critters. However, I did make this a stream player 2D, which means if it plays on the left side of the screen, the sound will come out of my left hand mic, and if it's on the right or headphones, it'll come out of the right hand side, and I kind of want to keep that. So I do kind of need to have this play from the enemy and not just say put it up here on my level. If I just put it somewhere on my level, then it wouldn't necessarily play where I wanted it to. So I have a couple options. One, I could put a reference somewhere, create a spawn an instance of it, like using this type code, instance it out, play the sound, and then have it destroy itself. So it would add itself to the enemy snail and then delete it. But that's a lot of work, and I think we could just add it here. Now in a future video, we'll look at how to add it, and we'll use inheritance on this scene. So we'll use, it's not quite object-oriented programming like it is in code, but Godot is extremely powerful in that you can inherit scenes as well. So we may look at that in the future. But I think for now, let's just copy that over. So I can, I don't think you can copy these. I can copy the node path. We'll give that a shot. I don't think it'll work how we want it to, unfortunately. Yeah, we can't do that. So let's just go ahead and add that. So, oops, add, and it was a audio stream player 2D, and I think, what did we call it, splash? Yeah, I'll just copy it. So copy that, and then over here on the stream, I'll change it to load, and we'll go to sound, splash. Alright, so if I stop and restart this, I think now we should be okay. Get our player out of the way. Snail makes the splash sound, and he makes the animation, or the particles there. And our player still does it. I think we're looking pretty good. So now we've refactored the enemy snail and our player to be actors instead of just inheriting directly from kinematic body 2D. And we've refactored the code so that we moved as much of the code as we could into this actor script. So now our actor script has all this stuff about the health and the water and the movement, and we'll clean this up as we go forward. But I think for now this is a good start for cleaning up our code. So if you look here at the player script, we have the ready function, and then we have this big actor behavior, but we've eliminated a lot of code that was in our player script. And then we've also added a lot of functionality to our snail, because now he interacts with the water and stuff, and we did very little work to do that. But we've also not added any complexity here to this enemy snail script. So I think this is a good win, and I hope you enjoyed and learned something. And I think in the next video what we'll start doing is cleaning up this snail and making him a little bit more functional. As you probably noticed when you play, he just runs and jumps into the water, and he also interacts with the spikes there, and we probably don't want that to happen. So we'll look at making him be able to turn around and run back and forth, and also not collide with things that we don't want him to, like these spikes here.